Good morning, everyone. We are the 2018 NSPS team from the University of Akron in Akron, Ohio, and we're here to present our project on surveying service. I'm Jacob LaRue. I am a senior in the program.
I'm James Galley. I'm a junior.
I'm Chase Summers. I'm a freshman.
I'm Aubrey Tobin, and I'm a junior.
I'm Jake Stair, and I'm a senior.
The scope of this project is to perform a survey in a developing country, so you may not have necessarily the tools and technology you're used to here in the United States, but you would have access to your computers and other software that you could take with you. This would make you perform operations on the fly and learn how to use the equipment effectively and efficiently that you've had at your disposal.
In the beginning, some of the equipment data that may have been provided to us by NSPS were things like optical theodolites, or a electronic theodolite, or maybe a total station that we were going to be able to use. We ended up just receiving a field book once we were on the site. We were gracious enough to have some equipment donated to us from a local company known as Nevada Transit and Laser. That's helped cut our costs for shipping and traveling. They were able to provide to us two tripods, 2 automatic levels, and then also the Philadelphia rods, and then just the remaining of the equipment and materials we needed based on the list we had to travel with us.
For individual safety, every single one of us wore work boots, long pants, and safety vests while out in the field, and most importantly, just to dress appropriately for the weather. We all wore hats to help keep the sun out of our eyes, as well as safety glasses and bandanas to protect our eyes and faces from blowing dust. It was also recommended that we wear sunscreen, but we didn't really use as much as we should have. As part of our safety plan, there was a recommended amount of water to drink while we were out in the field and even to stay hydrated before coming to Las Vegas. We also carried a Red Cross first aid kit with us at all times, as well as a snake bite kit. We were also aware of all the signs of fatigue and dehydration, just to look after each other and even just look after ourselves, and to be aware of the weather conditions just in case there was like a torrential downpour and a flash flood had the possibility of occurring, and that can cause a danger on the work site. And just to be mindful of this environment, since for most of us we've never surveyed in the desert before, and to be aware of dangerous species that might happen to wander across our work sites, such as scorpions and even snakes. We also had an emergency plan just in case one of us was to become seriously injured and would have to be taken to an urgent care close by an advisor.
So leading up to the competition, we practiced with several different pieces of equipment that we felt we may be using based on the original criteria we were given, starting with the non-robotic total station. And we used this to run a traverse as well as shoot multiple side shots. Next, we used a compass, so we took this outside and obtained a bearing, and then we compared that bearing to a known bearing, and we repeated that multiple times to ensure precision. And next, we used the steel taping. We practiced this both horizontally and slope taping, just in case. That way we were prepared for any types of elevation that we may encounter. And finally, we performed stadia using an optical mechanical theodolite and the 3-wire method, which allowed us to compute both the distance and elevation of our points.
Once we arrived here, then we actually received our project specifics. Those were basically the 4-corner boundary that we would need to lay out of a lot, and then create a site detail map of the topography within and around that lot, utilizing the level and Philadelphia rods we received. And then we were given the actual parameters, so we had the 1-acre lot and its location, and then we were also given a known bearing on a lot line, ours being north 10 degrees east, and then we were given the center point location for the northern easting and elevation of that point.
First part of our methodology was to set a basis of bearing with our handheld compass. So once we got onto the lot, I used the Brunton hand compass, which measured to the closest degree. I had to figure out where north was originally, so I took multiple readings around the lot. And once I finally determined an accurate measure for north, I took up position south of the benchmark, had Aubrey hold a marker on the benchmark, and had Jake pace out a rather long distance past our northern boundary in order to get a good sight reference, or a good true line of sight. I sighted through Aubrey to Jake and brought him into line with hand signals, because it's so windy it was rather difficult to yell. Once I got him into line, I had him set a marker. After that was set, we switched positions, and I went to his position, set up behind that marker, and sighted back and got a southwest bearing of south 10 degrees west. I was actually looking for south 22 west, which incorporated our declination of 11 degrees and 42 minutes. I decided to round it to 22 because it was plus or minus 20 minutes. I figured 22 degrees would be the best accuracy I could achieve with the compass that I had. After that was achieved, we set up an auto level at the southern end of our marker, in line with our southern marker or benchmark and our northern marker, to make sure everything was in line and accurate.
Okay, so next up we began laying out our 4 property corners. And to start with that, we began by calculating the distance of our property lines, the boundaries. And once we did that, we knew the property was square, thus creating right triangles, giving us the ability to use the Pythagorean theorem. From there, we used the Pythagorean theorem to help us calculate the distance from that benchmark, the center point, out to both the intended corner and also from the benchmark to the intersection of the basis of bearing and the property line. So then after we set a point there at the basis of bearing and property line intersection, we could then begin distance intersect taping. So for that, we simultaneously taped from the benchmark to the intended corner, and then we taped from the benchmark from the midpoint of that southernmost line to the intended corner as well. And where those 2 lines met gave us a good general idea of where that point was going to be. Then from there, we narrowed it down even more and did each line individually to give us a little higher accuracy. So we started from the benchmark in the center and went to that property, the intended corner, and then we also separated off and then went from the midpoint of that southernmost line to the intended property corner, and then we knew exactly where we needed to set that point.
Given the tools we had, the grid method was by far the best choice for topoing the property. We, just by eyeballing the property and seeing just the terrain features, we figured the adequate spacing that we felt we could most accurately represent the property with. We used Chase and Jimmy as human range poles that would pace down the ends of the lot that would keep Jake online as he walked and paced in between them with the pole. I read the instrument and Aubrey took the notes. We used multiple benchmark checks, usually in between every 3 rows or so, just to make sure everything was still secure, the level hadn't moved in the wind or shifted in the ground.
So the day after we did all of our field work, we did our computations, and Jake was the one who did most of our level note reduction. So what he did was he took the rod reading from the benchmark and added that to the given elevation of our benchmark to achieve our instrument height. Then from there, the foresight was subtracted from our instrument height to get the ground elevation. Then once he did all that, I double checked his work just to make sure the measurements were accurate and no mistakes were made.
We were given by NSPS during our nightly meeting an expected or goal to shoot for of 1 in 5,000. Given the conditions and the tools we had available to us, we figured a very adequate standard would be 1/3000, being that it was only a 1 acre lot, and you do not have to be off very much at all on a 1 acre square lot for your reduction ratios to start going down. We achieved a goal of 1 in 3,970, so we made it above our mark, and we felt that was very good given, again, the tools and conditions we had to work with. Errors and limitations we had, magnetic interference. Like Jimmy said, we took readings from multiple points on the line, making sure that our baseline was very secure before we started this project. We based our whole project off that baseline. And weather, as stated also, the wind paid a great toll doing compass readings, Philadelphia rods, basically almost anything that required a steady hand. CAD grid layout, no data collectors, you couldn't just plug it in and go. You had to establish your grid, you had a hand to put in all the elevations. It took a lot more time than it normally would. And time management, some things, especially in CAD, just took way longer than we had a lot of time frame for.
Some other errors and limitations we encountered, of course, like Jacob mentioned, and the steel taping, wind definitely caused an error. And then to avoid any need for sag correction, we actually use a 300-foot canyon tape and steel tape clamps that we could pull to a decent tension to avoid having to calculate that. And then, of course, temperature was ideal at 68 degrees, so we didn't need any correction for that either. And then your big blunder is just your expected equipment. You could go to a job site and expect your equipment to work, and it ends up not working, so those are obstacles you have to overcome. And then equipment provided also. We were expected to have some things, and we may have not got those, so we had to overcome that. Human error is introduced into every job we do, whether it be an error in a reading, an error in a calculation, writing a note down wrong, things like that. Those are all obstacles you have to overcome. And then group size was a big thing. We felt we could have used, in certain areas, more group members. If you want to have better steel taping, it's a lot easier when you have more people on each end of the tape.
For the mapping portion of our project, I was able to input the north and south coordinates of the given benchmark with the known elevation. And after that, I was able to project our calculated basis of bearing and distances. I was then able to create a layer that created our grid. And with that, every intersection that we took a Philadelphia rod reading, we were able to put our calculated elevations at. And then once I was done doing that, I was able to disable that grid layer and generate a contour surface model of 1 foot contour intervals. And then after that, I was able to work on the map annotations with the given 1 to 20 scale. I utilized Leroy scale to make sure that the lettering was up to par and fit the standard. And after that, we created the title block, which held all our marginal information, such as our university team members and logo.
So once we completed this project, we looked back and a few reflections that we had, some of the major points. The equipment, like Jake said earlier, you never really know what kind of equipment you're going to get. And that's very true, especially when surveying with service and stuff. You never know what kind of equipment and accuracy you're going to have. Preparation versus reality. Like we prepared a lot using specific pieces of equipment, and we ended up only using one of those pieces of equipment. So that can happen in any job. For surveying, you might prepare for something and end up not actually having what you prepared for. And then finally, just the impacts that we can have on these developing countries. We had a student from Gambia come through the University of Akron, and then once he was done with his program, he went back to his home country in Gambia, along with some equipment that we donated to him, and he used that knowledge to not only teach others about the profession, but also to provide services to them.
We used Galini's Elementary Surveying book through many of our computations throughout this project. And thanks to our sponsors, without them, we couldn't get this far.
Questions from the judges?
Yes, sir.
When you were laying out your boundary with your tape,
came down the first time, we had 2 men on each chain, and we did our best we could, got it within a softball size area.
2 chains?
Yeah, we had 2 chains, came in from both directions. And then came in with all of us on the same chain, pulling as tight as we possibly could, and got a very accurate reading within that area. So I guess a total of 4 times to each corner.
Yeah, can you discuss how you confirmed the 1-foot contours and the vertical precision?
We did a couple different methods throughout that. One was just like how you calculate the contours doing paper drafting. We did the same calculations by hand, and we just in CAD measured over to see how our contour lines cross between our grid points based on hand calculations. And every time we hit within, at least the ones we checked, we did spot checking, and within a foot or so. So that's very good for contour lines.
Other questions from the judges? Okay, then we'll
Yes, sir.
take questions from the audience. Start with students. Any students have any questions for the team from Akron? Any practitioners?
How did you calculate your horizontal precision?
We had multiple check shots we did throughout, or multiple tapings we did. Like at the very end, just for example, we did do direct line. Since instead of doing triangles, we did direct as we could measurements around there as accurately as we possibly could within the conditions we had. Then we used those measurements between the directs, having range pulls on each setup as part of our calculations. We also added the existing measurements from diagonals we did through the center of the project. Obviously, we didn't have any angle measuring devices, so we were forced to hold our angles. So, well, hold our distances, not our angles, I'm sorry.
Any other questions?
Oh, one here.
Sorry, I just wanted to confirm, I thought I heard, so you didn't account for sag, did you have like tension pullers to account?
We had steel tape clamps, so we could clamp on each side, and then the actual canyon tape is a very, very thin tape, so it basically neglects any need for sag correction. We would have corrected for temperature, but it was at the perfect 68 degrees right around there. So.
And we also, like you said, we don't have any tension pullers, so really the amount of tension you're pulling is kind of a guess at that point. And so on our accurate measurements, we had all men on the chain, so you had one person on each end. What their own job was to do was to pull as hard as they absolutely could. So we had that thing pulled extremely tight.
Time for maybe one more additional question, if there is one. Not? Okay, thank you.
Thank you, guys.